Have you ever wondered if we could use Earth's magnetic field for propulsion? Imagine the planet beneath you, with a force unseen emanating from its core, extending into the vastness of space. This is Earth's magnetic field, a silent but powerful force that not only shields us from solar radiation, but also provides us with a compass direction. Now consider the marvel of magnetic levitation, or maglev trains. These high-speed vehicles float above their tracks, propelled forward by a symphony of magnetic interactions. The mechanism behind it is the magnetic field. By cleverly manipulating these invisible forces, we've been able to create an entirely new mode of transportation. This leads us to a tantalizing question. Could we extend this principle to more ambitious applications? Could we, for instance, harness Earth's magnetic field to propel something as heavy and complex as a jet fighter? A daunting challenge indeed, but one that provokes our curiosity and our desire for innovation. But could we apply this concept to something as heavy and complex as a jet fighter? Imagine a jet fighter suspended and propelled by magnetic forces. This idea might seem like it's straight out of a science fiction novel, but in theory, it's not too far off from how magnetic levitation or maglev trains operate. Picture this: a jet fighter, not unlike a maglev train, but operating on a much larger scale and in 3 dimensions. It's a thought-provoking concept, isn't it? To make this a reality, we would need to manipulate Earth's magnetic field in different parts of the aircraft to achieve directional control. Think of it like a dance, where the aircraft and Earth's magnetic field are partners, constantly adjusting their movements in response to each other. Increase the magnetic interaction on the left side of the aircraft, and it's nudged to the right. Boost it on the right, and it veers to the left. By subtly shifting the intensity of this magnetic interaction, we could theoretically steer the aircraft with precision. But what about the energy required to generate these powerful magnetic fields? It's one thing to imagine this magnetic dance, but another thing entirely to power it. Traditional fuel won't cut it here. We'd be looking at significant energy sources, onboard batteries, nuclear power, or other advanced energy technologies. Whatever the source, it would need to be capable of generating and controlling incredibly strong magnetic fields to lift and propel the heavy weight of a jet fighter. As we delve deeper into this concept, we begin to realize that the mechanics of magnetic propulsion are far from simple. They're complex and multifaceted, requiring a delicate balance of power, control, and precision. It's a daunting challenge, but one that could potentially revolutionize the way we think about propulsion. However, every innovative idea comes with its own set of challenges. Harnessing Earth's magnetic field for propulsion is not without its hurdles. A concept as radical and fascinating as this undoubtedly presents some significant challenges that need serious contemplation. Firstly, let's consider the altitude limitations. The strength of Earth's magnetic field decreases as we move further away from the surface. Although it extends thousands of kilometers into space, its strength diminishes rapidly. This means our magnetic propulsion jet might face restrictions concerning its effective operational altitude. Then there's the question of environmental impact. Generating strong magnetic fields could potentially affect everything from migratory patterns of birds to the functioning of electronic devices on the ground. The full extent of these environmental impacts is still unclear and would require extensive study before we could even consider implementing such a propulsion system. Safety, of course, is paramount. In regions where Earth's magnetic field is weaker or behaves unpredictably, how would the jet respond? And what if the magnetic propulsion system fails mid-flight? Having reliable backup systems and redundancies would be crucial to ensure the safety of the crew and the aircraft. Another significant challenge is the energy source. Even if we're not burning traditional fuel for thrust, we'd still require a considerable energy source to generate and control the powerful magnetic fields. This could come from onboard batteries, nuclear power, or other advanced energy sources. But each of these options presents its own set of challenges and considerations. Lastly, we come to the issue of space transition. Once the jet moves outside the influence of Earth's magnetic field, it would need to rely on traditional or alternative space propulsion systems. This would necessitate a complicated and potentially risky shift in propulsion methods mid-flight. Despite these challenges, the idea of magnetic propulsion pushes the boundaries of our current understanding and could pave the way for future innovations. So, while we're not quite ready to build our magnetic propulsion jet just yet, who knows what future research might uncover?